look at the Moivre's theorem. Now, when do we use the Moivre's theorem? For instance, if I have a complex number, z is equal to a plus bi. And let's say I have it to a power, that means z to the power of n, which means I have a plus bi to the power of n. That means I want to find the power of a complex number. That is when we apply the Moivre's theorem. Alright? Now, what's the formula for the Moivre's theorem? The Moivre's theorem says if I have z to the power of n, I want to find a complex number to any power. Alright? The formula is going to be equal to r to the power of n into bracket cos n theta plus I sine n theta. Alright, this is the formula. Now, for instance, let's look at this example. Let's say we want to find the power of 1 plus I root 3 to the power of 5. 1 plus I root 3 to the power of 5. Now, mind you, I can also write this question as what? 1 plus root 3i to the power of 5. So each of the ways you see them written, they still mean the same thing. All right? So we want to find this to the power of 5. How do we do that? We first have to find the modulus. All right? So r is the modulus. R is the modulus. R is the modulus. And the formula for the modulus is square root of a squared plus b squared. Alright? And we also have to find the argument. Alright? So theta is the argument. Alright? Theta is the argument. Alright? More like the angle. Alright? So theta is the argument. And the formula for the argument is what? The formula for the argument is theta is equal to tan inverse of b over a. Alright? So we get the modulus by taking the square root of a squared plus b squared, which is this a and then your b here. And then we get the argument by using tan inverse of b over a. So now that we know all this, let's find this to the power of 5. Like I said, we first have to find the what? Modulus and the argument before we can solve this. Now, if you look at this, if you compare this to this, all right, you'll find out that your a is equal to what? 1. And then your b is equal to, compare this to this, is equal to what? Root 3. All right, so let's find our modulus. Our modulus r is going to be equal to square root of a squared plus b squared. Now, what is our a? Our a is 1. That's going to be 1 squared plus, what is our b? Now, our b is going to be root 3 all squared. So that will be root 3 all squared. So r is going to be equal to square root of what? 1 squared will give us 1 plus the square will cancel square root here. You have 3. All right. So this is going to be equal to what? 1 plus 3 gives us what? 4. And square root of 4 gives us 2. So our r, which is our modulus, is equal to what? 2. Now let's find our argument. Now theta is equal to what? Tan inverse of b over a. What is your b? Your b is what? Root 3 over, what is your a? Is what? 1. Alright? Your a is 1. Alright? So now we're going to have that theta is equal to tan inverse of, now root 3 divided by 1 is still root 3. And tan inverse of root 3 gives us what? 60 degree. Alright? Gives us what? 60 degrees. So meaning that the modulus of this is what? 2, and then the argument is 60 degree. Now we can put this and this into the formula here. So meaning that 1 plus root 3i all to the power of 5 is equal to r to the power of n. Following this formula, what is our r? 2 to the power of 5 into brackets cos n theta. That's going to be cos n theta. That's going to be n times theta. Our n, of course, is 5 multiplied by what? Our theta is what? 60. All right, plus I sine n theta. Our n is also 5 multiplied by the same 60. All right, we close the bracket. So this is going to be equal to 2 to the power of 5 gives us what? 32 into brackets. Now 5 times 60 gives us 300. That will be cos 300 plus I sine 300. All right. Now you can see we are very close to the answer. So what is cos 300? Cos 300 is going to be 32 into bracket. Cos 300 is 1 over 2. Now what is sine 300? Sine 300 is minus root 3 over 2. So this is going to be minus I root 3 over 2. All right. Now when this multiplies this, we're going to have what? What are we going to have? We're going to have this multiply this. We're going to have 32 over 2 minus I 32 root 3 over 2. All right. So when 2 goes here, we have 16 minus when 2 goes here, we also have 16 root 3I. All right. Or we put the I here. We can also write this like or 16 minus I 16 root 3. Any of this is an answer. Or you can also factorize and write this as 16 into bracket 1 minus what? Root 3I. All right. So this is our answer. Any of these, all right, is our answer. All right. So when you take this to the power of 5, all right, you're going to have what? 16 minus 16 root 3I, or you're going to have 16 into bracket 1 minus root 3I. So this is how to use the Moivre's theorem to solve a complex number to any power. Make sure you like this video, share this video, and hit the subscribe button. And after you hit the subscribe button, also hit the notification button.